Welcome to this example of a CableCALC Pro calculation. CableCALC Pro is powerful electrical software which fully complies with the latest standards. Visit our website cablecalcpro.co.uk for more information and to download the software. In this example, I'm going to show you how to determine cable size, voltage drop, appropriate correction factors for the installation conditions, and I'll also perform an earth fault loop impedance calculation. In this example, the installation will have a three-phase supply. We'll use a multi-core copper conductor. The cable will be armoured XLPE type cable, and the cable will be buried directly in the ground. Next we'll move to our load tab. Loads can be entered either directly into the program or they can be accurately determined using the maximum demand diversity calculation program from within CableCALC. In this example, our load will be 55 amps at a power factor of 0.9. The circuit arrangement will be radial. We can have other types of circuit arrangements such as ring or motor type circuits. Next we'll move to our supply tab. Our three-phase voltage is by default 400 volts phase to phase. This can be changed. In this example, we'll ask CableCALC to determine a cable size for a maximum voltage drop of 2.5%. The length of the run will be 40 meters. Our upstream fault level will be 6 kA with a source impedance of 0.35 ohms. The frequency of supply will be 50 Hz. Next we'll use the program to determine appropriate correction factors for the installation conditions. In this example, the ambient soil temperature for our direct buried cables will be 30 degrees Celsius. The depth of burial should be 1.5 meters. Our circuit will be grouped with other circuits. There will be a total of 3 circuits. Those circuits will be separated by 0.25 meters. The thermal resistivity of the soil is known to vary from default. CableCALC determines an overall correction factor which should be used to determine the minimum conductor size required. Finally, we'll move to our protection tab. Our protective device will be providing overload and short circuit protection. We'll choose a Type B miniature circuit breaker of 63 amps. We'll return to our cable tab. Go ahead and calculate minimum conductor size. CableCALC returns an active conductor size of 25 square mils with a spare capacity of 7.6 amps. Our earth cable size should be no smaller than 4 square mils. Our actual voltage drop is 3.17 volts, which equates to 0.79%. Our actual fault loop impedance is shown here, indicated as compliant. We have additional information available relating to short circuit performance. Our effective circuit current rating is 68.4 amps with a 0.71 correction factor applied. Our tabulated cable current rating is 96 amps. References to the British standard. Temperature correction factor used by the program to calculate voltage drop. Our conductor resistance and reactance. Again, references to the British standard. From here we can save files. We can also produce